Welcome to Section 1, Introduction to Data Structures. Data structures are the building blocks of computer science. They are ways to organize and store data efficiently. Imagine a library with thousands of books. Without a structured system, finding a specific book would be impossible. Data structures provide that system for computers. Just like shelves, categories, and indexes in the library, data structures allow for efficient data storage and retrieval. From simple lists to complex graphs, each structure has unique properties. These properties determine their suitability for different tasks. Understanding these structures is key to understanding how computers process information. Moving on to Section 2, Understanding the Queue. A queue is a common data structure that follows a specific order of operations. This order is first in, first out, or FIFO, much like a real-life queue. Think of a line at a ticket counter. The first person in line is the first to get their ticket. Similarly, in a queue data structure, the first element added is the first one processed. Adding an element to the queue is called enqueuing, and removing an element is called dequeuing. This simple yet powerful concept is fundamental to many computing applications. It ensures that data is processed in a fair and sequential manner, preventing data loss or unfair prioritization. Lastly, Section 3, Queues in Everyday Life. Queues are everywhere in our daily lives, often without us realizing it. When we print documents, the printer uses a queue to manage print jobs. Each job is added to the queue and processed in the order it was received. Another example is online video streaming. When you buffer a video, the data packets are queued and played in the order they arrive, ensuring smooth playback. Even traffic lights use queues. Cars waiting at a red light form a queue, with the first car in line moving first when the light turns green. These real-world examples highlight the importance of queues in maintaining order and efficiency. Section 4. Importance of queues in technology. Queues play a crucial role in various technological domains. In operating systems, queues manage tasks, processes, and resource allocation. For instance, when you open multiple applications, the operating system uses queues to schedule and execute them efficiently. Networking protocols rely heavily on queues to manage data packets. Routers use queues to buffer and forward data packets, ensuring reliable data transmission. Without queues, our digital world would be chaotic and inefficient. Understanding queues is essential for anyone interested in computer science, software development, or simply understanding how the digital world works. They are a testament to the power of simple concepts in solving complex problems. Section 5. Conclusion: Queues drive our digital world. Queues, though a simple concept, are a fundamental data structure with far-reaching implications. From managing print jobs to enabling seamless video streaming, they are essential to our technology-driven world. Their first-in, first-out principle ensures fairness, order, and efficiency in countless applications. Understanding queues provides a glimpse into the elegant solutions that underpin our increasingly digital lives. As we interact with more sophisticated technology, appreciating the role of fundamental data structures like queues becomes ever more important. They are the unsung heroes of our digital age.